So let's take your addition and subtraction, and we're going now to apply things to equations. So we're going to solve for x. Haven't done that in a while. Let's start off with monomials. So let's say we have the problem 7 over 2x minus 3 over 5 equals 1 over 10. You still need to find a lowest common denominator. So in this case, looks like 2 and 5 both go into 10. So our lowest common denominator will have a 10. And then we also need to include the variable. So 10x would be our lowest common denominator. But instead of making common denominators, we're going to multiply through by the common denominator. So everything will get multiplied by 10x. Still balanced because this is happening to every term. All right, so let's look at what happens. The 2 and the 10 reduce to 5, and the x reduce away. And then the 5 and the 10 reduce to 2, and the 10 and the 10 reduce. So we're left with 5 times 7, so 35. 2 times x times 3, so minus 6x equals x. Well, now this is a baby algebra problem. This is what you were doing when you were in diapers, I'm sure. So 35 equals 7x, x equals 5. Now double check that 5 is a good solution. Look in your denominators. If you put a 5 in for x, are you going to get a 0 here? Nope. So this is a great solution. If you got a 0 here, what would happen? Get rid of it. Bad. Okay, let's do something with binomials in the denominator now. So let's take a look at 8 over the quantity x plus 6 plus 8 over the quantity x minus 6 equals 1. So let's think about LCD. Lowest common denominator. This is just like what you were doing on the adding and subtracting. You're going to need both binomials. So x plus 6 times x minus 6. And we'll multiply every term by that. So times x plus 6 times x minus 6. Times x plus 6 times x minus 6. And times x plus 6 times x minus 6. I know it's not very pretty what I'm writing here. The x plus 6's reduce, so we're left with 8 times the quantity x minus 6 plus the x minus 6 terms reduce, so we're left with 8 times the quantity x plus 6 equals, nothing reduces over here, so let's just FOIL it, x squared minus 36. Distribute. 8x minus 48 plus 8x plus 48 equals x squared minus 36. 8x will combine like terms, so I've got 16 x's, and oh, that's nice. The 48s will subtract away, equals x squared minus 36. You've got a quadratic and a linear term, so let's make sure, whenever that happens, you've got to set the whole thing equal to 0. So x squared minus 16x minus 36 equals 0. And now we can use our factoring techniques, factors of negative 36 that add to equal negative 16. Let's see, 12 and 3, no. What else goes in? 9 and 4, no. What else goes into 36? 2, ooh, this might work, 2 and 18. There we go, found the winners. So x plus 2 and x minus 18. So our answer options would be negative 2, x equals negative 2, or x equals 18. So we want to check both. If we plug a negative 2 in, do we get a 0 in the denominator? No, we're good. So this is a keeper. Trying the 18, do we get a 0 in the denominator? Nope. So we have two solutions in this case. All right, let's try one more problem. And we're going to solve this guy, 2x over the quantity x minus 3 minus 6 over the quantity x minus 3 equals 9. Now our denominators are the same, so if you would like to, you can turn this into one fraction. You can say, or you can multiply everything through by x minus 3. Either technique will yield the same result. The x minus 3 is divide, so we're left with a 2x. The x minus 3 is divide, so we're left with minus 6 equals 9 times the quantity x minus 3. So 2x minus 6 equals 9x minus 27. Now some of you might have approached this problem differently. You could have combined your fraction and then cross-multiplied. That's totally fine. There's more than one way to do all of these. Subtracting 2x from both sides. This will give us a 7x. Add 27 to both sides, so plus 27 here will give us 21. So x equals 3. Now take a look, plugging it in. What's the problem here? What's going to happen if we plug 3 into the denominator? We're going to get zeros. So this one has no solution. So be mindful that that could happen. You could have 2 solutions. You could have no solutions. You might have 1 solution. So be aware. All right. You are done with rational expressions and equations at this point. So practice this one last worksheet, and I'll see you for the next section.